My name is Bashir, and I'm currently a postdoctoral research scientist at Lawrence Berkeley National Lab here in Berkeley, California. I'm an experienced AI and machine learning engineer with about 7 years of experience. And I'm currently working as a postdoctoral research scientist on a US Department of Energy funded project at Berkeley Lab, which we call the Deep Learning and AI High Performance Networks Project. So we call it DAPHNE. So just the same way you have self-driving cars, so we are trying to build self-driving networks, basically. So in my talk today, I'll be sharing some interesting real-life applications of AI, that's artificial intelligence and machine learning. So a lot of us will agree with me that AI has a lot to offer. But what is quite surprising is that a lot of people don't agree what AI actually is. So to help us understand, I've introduced this framework, which consists of the main components of AI. At the center here, you have 3 ways in which machines can actually learn, which is the supervised, the unsupervised, and the reinforcement learning. Now you will see that the cycle says deep learning, right? Now, of course, that's where there's been a lot of recent excitement, particularly with regards to robotics, image processing, image recognition, and all that. So deep learning can be combined with both supervised, unsupervised, and machine learning. Machine learning is an approach to achieve AI. And deep learning is one of the techniques of machine learning, period, simple. So one of my favorite interesting AI use case is the recycling. Okay, so now in this picture, what you see is that you have a recycling center. So there's a lot of garbage there's a lot of trash and garbage and some materials that needs sorting, right? And they are passing through what we call a conveyor belt. But some materials are passing through the incinerator, right? Like, and this can be reclaimed, like plastic bottle, for example. They have some sort of economic value, but they are being allowed to pass, and just go, go into the wrong recycling. So there is absolutely no economic value for you to employ a guy, okay, to put his hand to bring out these plastics and all that. It is smelly, it is dirty, and it's dangerous, right? But we might, because they might have some sharp objects, there might be a lot of things. It just doesn't make sense. And so as a result of this, a lot of economic value will go up the flame. So AI was perfect for this use case, and this was in California. Actually, this is in California. So what happened here was the AI and ML models, which is here, looks at the trash that is going down the conveyor belt, and it identifies the materials. So that's, you can see the robot picking up, what is being identified and putting it here. So what the human basically, we don't need any human to put his hand and start dipping on stuff, right? So this is a perfect AI use case scenario, which is currently in production right now here in California. So this was picking about 30 picks per minute when they started, but as I'm speaking to you now, it's picking 1 pick per second. So in each second, this robotic arm picks one. So that's really remarkable and fast, right? So, and they're able to get economic value, from all these things. So from the healthcare space, there's also been some interesting use case, particularly with how robots are used to treat patients and, how they are being used to diagnose disease. So this is Algorithmic Health, an artificial intelligence-based diagnostic startup in sub-Saharan Africa. And what they are doing here is they are using, these folks are using AI to detect and identify diseases in its early stage, which is super amazing. So in the developing world, we have a disease called TB, which is tuberculosis, and it's a serious infectious disease that mainly affects the lungs, right? So I'm gonna show you, so this is what it looks like. And here they're basically using AI to, identify, where the extent of the effect of tuberculosis, and it's been detecting it at the early stage. So we all know that when these things have been detected at the early stage, it's really definitely going to help and go a long way. So the last slide of my talk today will just give you some other overview about other areas of applications of artificial intelligence. So I believe, so the first one is Facebook facial recognition. I believe everyone knows this. When you upload a picture, Facebook automatically knows your friends, they tag them automatically. That's machine learning in action. We also have the virtual reality headset. When you turn your head and the picture moves, how does the machine knows that you're moving? How does the headset knows what to portray, right? That is machine learning, monitoring your actions and connecting them with the game, basically. We also have voice recognition. If you have an iPhone today, you can use this little icon where you can do speech to text or voice recognition. That's Siri. So it recognizes what you're saying and it types it in. That's machine learning. And the most interesting one on here is the robot dogs, right? These are trained using reinforcement learning so that the robot dogs, learns how to walk on its own. And this is machine learning in action. So there's a famous company I would encourage you guys to look up. It's called Boston Dynamics. It's in Massachusetts. It's a very famous company. They have a lot of materials and videos online. And I'm always engaged and looking at the amazing stuff they're doing around, building robots and all that. Then we have Facebook ads, right? They know you more than you know yourself, right? So Amazon, for example, Netflix, they all use what we call recommender systems to recommend. Those people who buy this always also buy this. Those people who watch this movie also. So you always see that after this thing. That's also machine learning in action.